We are ready. Okay, great. So I will launch right in now. What I hope to do, and I always do this, there are so many really cool things that I want to cover that uh, I really should ask for like 2 or 3 hours. But I can't go long because the guy who's following me is a real jerk. I'm kidding. Well, I'm sort of not. It's me. I actually have another talk after this one. So I don't want to run late with one talk and swerve into the next one. Wouldn't anyway for someone else, probably would be even more careful with someone else, but certainly I don't want to sacrifice one talk for another. So I will be trying to wrap this up on time or maybe a few minutes early. If we can do Q&A at the end, that's great. If not, by all means, ping me afterward. Or if you think of something like I typically do, 10 minutes after I walk away, that's when the best questions and ideas and comments always come to me. So if that happens to you too, by all means, do reach out to me via email or Twitter. I'll share that with you momentarily. So let me share my screen and we will get rolling. So let's see. Yeah, this one. Wow, I almost clicked that leave button. It's right below share. That would have been embarrassing. Okay, so hopefully you can see my screen now. Can I get a confirmation of that really quickly? Someone, anyone? Yes. Okay, good. Good. That is exactly what's supposed to happen. And things always go exactly like they're supposed to on live demos and presentations and stuff. So but anyway, so welcome to this afternoon session on Game of Streams. Thanks for coming. From wherever you are sitting or standing at this point in time, thanks for being here. I like to call this talk or kind of summarize it or subtitle it, How to Tame and Get the Most from Your Messaging Platforms. I'll get into why momentarily, but suffice it to say that messaging platforms are underutilized and they're a super powerful, tool in your toolbox. So my name is Mark Heckler. I am a Spring developer and advocate with VMware. I am on the Spring team. It still seems weird, like most of the year into it after Pivotal was acquired by VMware, which is strange in and of itself because Pivotal was actually kind of spun out from VMware a few years ago. But we found that we worked on so many things together. There were so many complementary areas that when VMware said, hey, we'd like to bring you back into the fold, it kind of made a lot of sense, right? Because of all the projects that we were working on directly together or even indirectly together. So here we are. We're one bigger, happier family, still largely the same teams doing the same things. It's just a little bigger footprint. So that's kind of cool. I blog not as often as I'd like, admittedly, at thehecklers.com. If you have any questions, comments, or feedback later or a week later or a month later, whatever, I do check email from time to time. I'm not quite as rigorous about that as I am Twitter, though. So you're welcome to email me. I do get on there. I do respond. But if you want the fastest possible response or to kind of tap into the pulse of where I am at this point in time, physically, mentally, whatever, Twitter is the way to go. And that's the bottom line there, MK Heck. So please do reach out to me. If you want to ping me and ask questions, comments, provide feedback, whatever, publicly, that's great. If not, my direct messages are open. So just DM me. A little bit about myself. I have co-authored a couple of books, contributed content and code to several other books, have another book in progress, which I will mention here momentarily. I am an architect and developer, and as you might surmise from the next point where most of my expertise has been won, it's been in the JVM ecosystem. I am a Java champion, Java 1 rockstar, groundbreaker ambassador, a Kotlin developer expert with under the Google program, actually, which is kind of cool, nice. So you might suspect from that I do a fair share of Kotlin development as well as Java, which is true. Love them both. I don't have, okay. I have favorite children in different contexts, right? But they're both my favorite children, I guess you'd say. I am a Spring developer and advocate with VMware. Work on the Spring team. I am the sole creator and curator of Spring Noticias en Español. Si eres hispanohablante, déjame extender tu voz. If you are not a Spanish speaker, that's cool. Just ignore what I just said. But this was an area that I felt I could contribute to because I speak Spanish, slightly worse than I speak English, which both are terrible, admittedly, but thanks for coming anyway. But I felt it was an area that I could help kind of collect resources and share them with the broader community. So that's what I do, right? That's a personal and professional passion of mine. I am also a licensed pilot. It's amazing the trust that the government organizations will place in you when all you have to do is pass a rigorous written exam, a rigorous oral exam, and a flight test. But here I am. So that's something that I enjoy doing in my copious spare time. So rarely, but once in a while, I get out and get in the air. So that's kind of nice. I do have actually, you know what? I'm kind of covering this, aren't I? So you probably can Yeah, does that help? Okay, so I have a new book coming out soon. Hopefully, I just wrapped up another chapter. I have just a small handful of chapters to go, but I'm working furiously on them, and hopefully we'll have them done here in the next few weeks. But it's called Spring Boot Up and Running, as you can see. It is available for early access if you'd like to kind of kick the tires on it. O'Reilly does allow, I think, the first 4 or 5 chapters where you can read them for free. Once it's finally released, it'll be available at all your favorite booksellers online, physical probably too. Yeah, so if you have a Safari Books Online or an O'Reilly subscription, you can get that as well via that. Read it from there. But yeah, I'm pretty excited about that, and getting to share some of the things that I like best, as well as just kind of provide that on-ramp for folks who may be new to the Spring Boot ecosystem. Because with every passing day, you have new people coming into the Spring Boot ecosystem. They may have years of experience in another tool chain, but this is somewhat new to them. Or they may have experience in Spring Boot, but they haven't touched a particular component or capability that's been added or that's been expanded over the years. So happy to help kind of fill that gap. So if you're interested, check out the URL. Why didn't that switch? Yes, time check. Okay, so we are exactly 6 minutes into our talk, so that's good. That's enough about me. So let's get into the talk itself. I like to kind of just introduce myself, then introduce what I'm going to be talking about, and then just go code, right? But I think it's important to have context. And that's what this slide starts with, right? Because how many of you at the end of last year, let me just ask it this way. How many of you at the end of last year had your boss come up to you and said, hey, great job. You did phenomenal work. I would like to increase your budget, and could you slow down a little bit? Because your output was way too high. Your team did way too much, and you did it way too well. Yeah, that never happens, right? I'm still looking for the one case of that happening so I can write up a big report, get published in all the trade journals, and retire early. I don't know. But yeah, I mean, typically we're asked to do more with at least the same budgets, right? Sometimes more with less. And that's why talking and looking at things that we already have in our stable of tools, in our toolbox, or that we can easily add to our capabilities is so important, right? Because we have a lot of opportunities to add new and shiny, great tools, and they are superb at solving problems. But we also have a lot of tools in our tool belt that maybe we haven't really paid full attention to, or that we haven't fully exploited. So that's kind of where we are with this particular session today. So first I'll talk about why I use messaging platforms, where do they fit in a distributed architecture, and then we'll go into some other things. But starting off with that, I'm going to kind of skip over the part where we have decided that maybe monoliths don't solve every problem, right? Because like any architectural choice, they have their pros and cons, but the scalability is not one of the pros of a monolith. Whoops, I bumped the keyboard. I tend to talk with my hands, and if you can see me as well as so yeah. I enjoy what I do, right? So this is, I get excited about this. But yeah, so if you accept at some point that your monolithic architecture is not going to allow you to scale to the level of granularity and to the extent that you want or need to scale, at some point you start teasing out microservices. And when you do that, you typically start with an HTTP-based model, like a REST API or something. And you start realizing at some point that those don't scale necessarily the way you expected them to, because you don't tease out a microservice, you tease out clusters of microservices. And when you tease those out and you have these small clusters of microservices that interact, typically you have kind of a linear scaling between those. If service A talks to service B and you need to scale service A out and have 2 or 3 or 5 service A's, you're probably going to have about 2 or 3 or 5 service B's in order to maintain the number of connections, the threads, the request handling capabilities, I should say, between those 2 services in that very simple example. Messaging platforms fit in very nicely because they allow you to detach in terms of, or decouple in terms of numerical coupling or locational coupling or temporal coupling even, because if service A sends a message and service B or any instance of service B is not online at the time that message is sent by service A, what happens? Well, in a messaging in a distributed architecture that involves messaging platforms, you can set up things like durable queues. You can have persistence, if you will, so that when that message hits the messaging pipeline, and I do try to stay, when I speak, in terminology wise, I try to stay at that higher level so I don't devolve into a particular brand of speak. But when that message hits the pipeline, It waits, right? It's there and ready to be consumed when a consuming service, service B in this case, comes online. So temporally they're decoupled, which is really, really nice. And when service B comes online and says, hey, look, I've got 152 messages to process, service A may not be online or accessible. Or maybe it is, and it just isn't feeding additional messages. Who cares? Service B just knows it has messages to process. It doesn't even need to know where they came from either. It just sees messages that are in its hopper, so to speak, and it knows that it needs to get those, process them, and either pass them on or finish that life cycle of that message. So it gives you a lot of decoupling capabilities and routing capabilities, because with messaging platforms, it allows you to take a message and send it to multiple different places, or to pass through multiple different stops, if you will, on all of the different paths through until the life cycle of the message is complete as well. So it gives you crazy flexibility that you may not have in other mechanisms that would pass messages or allow communication between multiple services. Some examples of leading messaging platforms, you have things like RabbitMQ and Kafka, which have kind of defined the industry, right? You have other examples as well. All of your major cloud providers have options. They, I think, also all run RabbitMQ and Kafka, but they also bring other things to the table, other options that they particularly embrace and espouse and field. So things like Amazon Kinesis and Google's Cloud Pub Sub and Microsoft's Event Hubs and Solus Pub Sub Plus, you have options, right? By the way, I like to kind of focus first on RabbitMQ and Kafka because they've been around a long time. Their performance and scalability and reliability are well proven. They are able to be fielded from everything from a container to a VM to a bare metal to a cloud platform, in-house cloud, public cloud. So you have a lot of options there. They're also, RabbitMQ and Kafka are open source, and the others are not. Now that may or may not be a concern for you, but I think it's worth pointing out, because if it is a concern for you, at least it's good to go in, aware. If it's not, great. You have other options as well. But RabbitMQ and Kafka are two extremely well-respected options. So I kind of look at those as perhaps the first among peers. Pardon me. Now, if you could standardize on one bit of capability, right? One bit of technology, and we'll just say this is a piece of infrastructure, even though that's probably not summarizing it extremely well. But I tend to think of messaging platforms as fitting into kind of an infrastructure role, because they're typically treated as parts of a critical infrastructure. If you're hosting it in-house, you typically view those, they're typically maintained and managed by your critical infrastructure team. And if you're using a public cloud provider's hosting for that, they're kind of treated the same way, right? So if you have, sometimes folks will ask, what happens if my messaging platform goes offline? Well, if that happens, probably everything is offline. So you've got bigger problems than that. But let's say that you could standardize on one. Perhaps your company has said, look, RabbitMQ is what we need to be using. That's the only thing we need to be using. Therefore, that's the only thing that will be approved and authorized for use within our organization's walls, physical or virtual. And that's great. And that works briefly, right? Because as soon as you interact with a partner or a customer, or your company is acquired or acquires another company, what if they use something else? Maybe they use Kinesis, maybe they use Event Hubs, maybe they use PubSub Plus, maybe they use Kafka. You're back in the integration game. Well, Spring Cloud Stream actually takes you out of that integration game, or at least gives you the tools to handle it with ease. Spring Cloud Stream abstracts, it sits on top of, if you will, at a higher level of abstraction conceptually, than a particular messaging provider. You still have access to all of the levers and knobs and dials underneath, but in most cases, as developers, once we get things established, what we care about is the ability to pass messages from one place to another place or several other places, have them route where we need them to be processed how they need to be processed, and then handle the entire life cycle, and that's it. So it's primarily a matter of getting messages or information from one place to another. We don't necessarily care about the plumbing underneath in most cases. Now, of course, when you need to tweak a setting, that's absolutely essential you do it. Therefore, we don't hide that or anything. But in Spring Cloud Stream's case, as with most things Spring, you focus on the things that make your job easier, that streamline the things that you have to concentrate on to get your job done. And then if you need to add something to that, it's easily done as well. So Spring Cloud Stream uses something called binders, and a binder allows you to kind of deal at that higher level of abstraction and yet connect to, let's say, Kafka or RabbitMQ or Kinesis, what have you. And again, it allows you to do a lot of things that you wouldn't have the ability to do otherwise. And I'll cover that momentarily here as we go. Why use it? Well, as I mentioned, it kind of gives you the ability to focus on the higher level concerns and deploy faster and in a more reliable, scalable, and certainly more consistent fashion. Now, if you have the circumstance, and I mentioned flexibility before, I probably should double back and hit that rather quickly. If you have the circumstance where things are likely or possible to shift under your feet, let's say you've standardized on Rabbit, and then at some point your CTO reads an article online and says, "Oh my gosh, well, we should be using Kafka." How much would it take? How long would it take? How much effort would it take to switch everything over to Kafka? Well, if that happens, uh, you need to have flexibility. You need to, who just kicked on my voice activated thing quietly, kick back off. Good. But if that happens, you need the flexibility to know that you can not have to stop the world to adapt to changing circumstances. So yeah, I mean, you can use a tranquilizer dart, or you can just use better tooling. And that's where Spring Cloud Stream comes in, because it gives you that flexibility. It gives you the superpower to be a bit more dynamic and to adapt on demand to changing environments. You can, I hope you don't need to, but you can, should the circumstance arise, switch the entire underlying messaging platform underneath with just a rebuild and redeploy. Or if you've thought ahead, you don't even have to do that. It's just a zero downtime switch. So I'll show you how to do that as we go. Really quickly, I'm going to plug together 3 services. I'm going to create just to get some messages flowing here. And then using Spring Cloud Stream and a messaging platform, I usually like to start with Rabbit, because Rabbit I've used for a long time. I love RabbitMQ. Pardon me. And I mean, typically you hear people talk about RabbitMQ and its flexibility in routing. You hear people typically talk about Kafka, and in terms of its crazy throughput. But neither one are slouches at the other, right? You have RabbitMQ, which has been proven. At the time, Pivotal and Google worked together just to see how far they could scale it. Just kind of a fun experiment. And they found that they could process more messages per second, minute, day, hour, whatever, because it works the same. Obviously, time is time. But they could process more messages than were created and passed through WhatsApp, iMessage, and all SMS providers in the United States in any given point in time, like almost 3 times the number. And that was RabbitMQ. So clearly scaling is not an issue for that. Kafka is the same way in terms of its routing. It has, Rabbit may be a bit more focused in that regard and have some significant chops in that area, but Kafka is no slouch either. So I guess what I'm trying to say is you do have choices. I'm going to start with Rabbit, but that's just kind of a personal preference thing. So in Spring Cloud Stream, historically, we've had 3 predefined interfaces. One's a source, one's a processor, and one's a sink. I like to tie those 3 together, just one example of each, although you can go crazy with that as well. But a source produces values, and that is kind of the origin of a message in this particular instance. A sink is the end of the life cycle. That's where the messages are, finished up, they're processed, they're done, right? That's the end of the road for any particular message. And in between the source and sink, you may have one or more processors which transform that message. They act on it. They do something with it. They manipulate it. They pass it on to other processors, perhaps, or eventually to a sink. This is kind of well, it's not the simplest example, because a source and a sink would be the simplest, but this is the simplest example that uses all 3. So I'm going to start off by creating a source, a processor, and a sink, tying them together via pipelines, RabbitMQ pipelines. And again, I'm staying at that level, so I don't say, hey, RabbitMQ exchanges and queues and Kafka topics and what have you, or mix it up, and that gets really confusing. And then we're going to talk scalability. Hopefully, if I have time. If not, I have all the code out in repos, and it's well marked, well delineated, so it's easy to see. But certainly you can scale, well, any of them actually, sources, processors, or sinks, in and out, right? So you can scale them out to accommodate a higher load, scale them in to when you don't need as much processing capability in any particular stage of the messaging pipeline. And I show you some of that as well as we go through. You have flexibility because, again, if the world shifts under your feet and you need to switch your entire messaging infrastructure, you can do that. It's very simple and easy to do that. Hopefully we don't have any bosses, VPs, CTOs on the phone or on the on the call on the phone on the Zoom. Yeah, so Zooming right now, but certainly it's not traumatic to do. It's probably not the best thing in terms of stability for your like mental well-being, your developer organization, but it can be done. So it's good to have that capability and flexibility. And then you have versatility in that you can actually integrate the multiple messaging platforms very, very handily. And I'll show you that as well. So I did mention source processor and sync. This is actually kind of the legacy API, because over the last year and a half, Spring Cloud Stream has undergone some transformations. And we realized that, Spring Cloud Stream was based on, of course, Spring Boot, which gives it a lot of capabilities, but it was also based on Spring integration. And Spring integration would allow you to tie together various different bits of infrastructure or different libraries, different sources and syncs and outputs and inputs. And Spring Cloud Stream actually kind of, pardon the expression, streamline that to focus on messaging platforms specifically. But what we realized is that if you were familiar with and comfortable with Spring integration, Spring Cloud Stream made a lot of sense, but otherwise you started seeing some abstractions leaking through from integration. So our team looked at that and said, look, maybe there's a way that we can actually eliminate some of the leaky abstractions and take this down closer to the language level. Right? Which brought us to the point of realizing that sources, processors, and syncs correspond really nicely with the language constructs in Java of supplier, function, and consumer, right? A supplier creates values, a function transforms values, and a consumer consumes values. That's the end of the line for a particular value, right? So this makes a lot of sense. And it allows you to write, if you will, and if you see this momentarily, you will, functions that act on our data that we're passing through these pipelines and really don't have a lot of Spring, if you pardon, that. They don't have a lot of Spring in them. They have more of the language itself versus the framework. So that's kind of cool, right? It keeps you as close to that metal as you can possibly get, which is nice. So I'll also throw in a few other useful bits and bobs if time permits. If not, hey, check out the repo. It's all in there, and we'll go from there. So let's code. So quick time check again. Let's see. Yeah, so about 22 minutes. So that's not bad. So we've got almost 40 minutes to go. That should be good for coding. So let's launch in. All right. So I'm going to go here. Oh, yes. In case anybody wonders, here we are right here. Yep. Game of Streams. So if you're in the wrong spot, if you just joined us and said, oops, that's not what I wanted to be, feel free to check out Nolan's or this NA person, and we'll carry on. So, oh, I'm already there. So let's see here. Let's go here. There we go. So this is the Spring Initializer. This is typically, if you're not familiar with Spring Boot-based applications, this is where you go to start your Spring Boot-based journey for building Spring Boot-based microservices. Now, you don't have to go here. You can start by building your own custom, bespoke, artisanal, handcrafted Spring Boot applications. Not the best use of your time, right? Because this allows you to kind of get off to that running start fast, but you can certainly go there. You can do that. You can also access the Spring Initializer via curl or HTTP, so from the terminal. You can access them from your IDE in most cases. And all of that, the cool thing about that is that the Spring Initializer exposes the API and gives you the same packages regardless of how you get there. So it's consistent. So if your buddy next to you, let's say she likes to use command line and she wants to access the Spring Initializer that way, that's great. Let's say you like to go to the actual page on the internet like I do, because it is kind of pretty, right? That's cool. You'll get the same exact artifacts downloaded to get your project started. I like a couple things about this, and they're small creature features, but they're so nice. So you can come in here. Yeah, that's blinding for me because I like dark mode. Or you can leave everything dark mode. If all your other tabs are dark mode and you shift to this, it's a little jarring, right? No pun intended. So I like it in dark mode, and that's a nice little extra. Not the end of the world, not be all do all, but it certainly is nice. And the Explore button, which I'll get to momentarily, is a very nice feature that, again, it's just a little bit of extra oomph that you get by coming to the initializer page, which is at, as you probably know from Josh's talk, start.spring.io. So it's a good place to visit anyway. Now, you do have options in the initializer. If you prefer to use Maven for your build system, you can choose to create a Maven project, Maven-based project. If you're a hipster, you can create a Gradle-based project. So you do have options. That's good. Life's good. I'm going to stay with Maven today because I am not wearing my hoodie at the moment. And I'm going to stay with Java. Although, again, I like Kotlin, big fan of Groovy too. But yeah, we'll stay with Maven and Java. That works. I'm going to use the current version of Spring Boot, which is 2.3.4. And if you're just coming to this recently, like in the last day or two, you probably noticed that the order has changed somewhat on this. So it's kind of nice. It goes this way. So yeah, something to note. Now I'm going to change the metadata just briefly to the hecklers.com for the group. We'll change the artifact to source because we're going to create a source, a processor, and a sink, as I mentioned. And let's get rolling with that. I'm going to leave the packaging as a jar because that gives you all of your components, your libraries, your dependencies bundled into one deployable unit, which is nice. By the way, if you're interested in some of the advantages of that and options for that, come to my next talk after this, and we'll talk about that as well. And then I'm going to choose Java 14. Don't have to. Java 8 is the baseline, right? So you can use back even to Java 8. Java 11 is a current LTS version of Java. That's fine. Java 14 is a current version. I'm going to use 14 because there's one thing in particular that I just find kind of useful in that I want to do today. So yeah, again, small thing, but pardon me. So I'm going to bring in a few dependencies here so we can create some apps, right? One will be the Spring Reactive Web dependency. And I'm going to just hit Command Enter so I can leave that open. Now I'm going to be creating reactive microservices, reactive applications that will tie this together. But the difference between reactive and non-reactive in terms of what I'm showing is fairly minimal. I'll try to point that out as we go as well, but there's just no time to show both. So I'm going to go with reactive, and I'll explain as I get into it why with that as well. But again, very similar, not a huge shift in terms of what we're going to be talking about today. I'm also going to add an actuator for some production ready capabilities, which I hope I have time to share. Those are really, really useful. I'm going to bring in Lombok because I'm a lazy developer. Lazy good, not lazy bad. I just like to focus on the stuff that I want to focus on, especially for demos. You don't want to spend a lot of time crafting pages and pages for a domain object of, getters, setters, and things like that. So I'm going to use Lombok to help along with that. And then I'm going to bring in Spring Cloud Stream. Now, if you look at this, it's so nice because it gives you the hint that, as I mentioned, it uses binders. So if you're using Spring Cloud Stream, you're going to want a binder like Kafka, RabbitMQ, or Solus PubSub Plus. So it gives you the hint. If I select that, you're going to want something with it. So I'm going to bring in Rabbit, and just why not? Let's see. So Kafka, I'm going to bring in Kafka as well. Can't make up my mind, right? So we have some dependencies here, and then I'm going to go down and choose to explore the project. And this is another nice thing that the Spring Initializer gives you is the ability to check out your project structure, of course, but primarily your build file, your dependencies. So you can kind of see what you're going to get before you have to pull the project down. So it lets you kind of check things over, verify everything is what you thought it would be. Is it all you wanted it to be? Very good. Okay, so we'll generate the project. I'm going to just save that out on my desktop as source. And then just in the interest of time, I'm going to go ahead and create my other two projects, processor, same dependencies. And we'll save that and sync. And we will save that. And that will get us off to a fast start, hopefully. So desktop, source, and we'll open that in our favorite IDE, NetBeans. Kidding. Lest anyone think I don't like NetBeans, I do. NetBeans has great Spring Boot support. It's just a super IDE with a lot of great development that's going on. Still continues to go on and invest in it. Folks invest in it. So it's a good option. You can see here, obviously, even the build file itself, the get ignore that comes in the project, I should say, accommodates and expects. Some folks will be using NetBeans. So great stuff. It's a good IDE. Eclipse is also a great, Eclipse is also an IDE, right? I'm kidding. Spring Tool Suite is based on Eclipse. We have full support for that. That's actually a build that we, work with and provide capabilities into, invest into. So that's good stuff. We also support things like VS Code. IntelliJ IDEA is what I use. because again, I do some Kotlin coding, and the folks who make IntelliJ, JetBrains, also guide and lead the development of Kotlin. So as you might imagine, support's quite good there. You can use whatever you want. You can even use Vim, right? Please though, don't use Emacs. Have some self-respect. Kidding. I'll probably get like hate mail now from the sole Emacs user out there still, but is what it is, right? Okay, so I'm going to go ahead and just open the POM. Yeah, that all looks good. Everything looks good there. That's nice. I'll go ahead and close that out. I'm going to also open my application properties. This is where you put your kind of sensible defaults, your properties that will be used in your application. And then we can override those externally via our environment, which we will do, right? So let's, I open that up just so we can come back to that here momentarily. And then I'm going to go to the code, the main application class. Now, the Spring Initializer doesn't, it's not a code generator. It does build your project structure for you. It does create this, right? This whopping, one line of code, or if you expand it, it's all of like, I don't know. Well, it's still just one, right? Really, when it all comes down to it. But what it does do is set up your project for you very nicely. So it gives you your dependencies, your starter POMs, and lets you get off and running to a fast start. So what I like to do is start off with the domain. Now, as I mentioned, I am a pilot. I am also an aviation enthusiast. And anytime you do any kind of demos, right, you're always kind of struck with, what do you share? What do you show? You got to have some real world working thing. Well, better if it's real world, right? Because if it's something kind of, simple and weak, I don't know. It's just not inspiring. I like real world stuff, and I like planes. So I actually have a couple of devices that scan the airwaves around, no pun intended from that, for planes in the area. So aircraft flying through the area are required in the US to provide position reports. So I can pull those in from the air. They're just broadcast. And I pull those in and I can query those. So that's kind of nice. And I thought it would make a great use case, because when I query those, I can process those messages as messages and pass them through the chain until they're transformed and they're consumed, and that's the end of the line. So we'll start off with that. I'm going to create a class, come on, IntelliJ, keep up. And I'm going to call this aircraft. So it's really, I guess, technically aircraft positions, but we're reporting on an aircraft at any given point in time. We'll have some things like, let's see, so call sign, right? Let's see here. I just want to make sure that I cover everything. I don't omit stuff. That's always a little embarrassing. Yeah, so I want to make sure I get the call sign in there, and of course the registration for the aircraft registration, the flight number, and the type of aircraft that it is. I'm also going to be bringing in the altitude, because we want to know where the plane is, where the height it's flying, the altitude it's flying at, the heading, where it's going, right? And the speed, how fast it's going to get there. And then of course I want to have double. So the lat and lon, so we get the position report, if you will. So that's not terrible. I'm going to use the data annotation from Lombok. So the Lombok will provide my getters, setters, equals, hash code, and toString methods for me. And then I'm going to, let's see. So JSON ignore properties, and I'm going to set ignore unknown equal true, so that if anything comes through that we're not expecting, that we haven't defined here, and there's quite a bit of detail that comes through normally when you get a position report. We're just concerned with this, so we'll just ignore that other stuff. Now I'm going to create a configuration class. This is not something you have to do to define beans in a Spring Boot application. However, because you can put them up here, right? You can define @bean, and that works when you go on blah, blah, blah. Because if you look at the Spring Boot application annotation, you can see that it actually has a lot of other stuff there. Let's see, come on, download sources. And we can see that it actually has the, configuration, Spring Boot configuration. And we go there and we see that it is a configuration class. So we don't have to break this out and define our beans in a separate class. I just like to. I think it's nice to keep things separated to some degree. He says as he puts everything in one file. But anyway, this is a demo. So, okay, so this will be our, let's see. So this is our aircraft sender class, right? So I'm going to create a bean, or I would, but actually what I'm going to do is create a pullable bean, and I'll come back to why I do that momentarily. I keep saying that, but there is kind of a natural flow to things. But what I want to do, well, I'll just cover it now. Why not? So with the device that I have that scans for positions of aircraft within range in the area, what it'll do is it will report a group of aircraft, however many are in range at that point in time. So it may be 0, it may be 1, it may be 10 or 50 or 100, although due to reduced flight numbers right now, it's usually a small number, so 10, 20, 50, whatever. So it's a small number, but they come in a listing, if you will. And I say listing. Technically, it is kind of a list because it's just your standard imperative type, right? So it's your standard Java type that is coming in via JSON when you query it. But what we want to do is take that, and we'll take that grouping of aircraft positions, and then we will pull and grab the next grouping and the next grouping and the next grouping. So it's not this kind of reactive flux, this publisher that's evenly spaced. It's clusters. Every so often. So we want to create a pullable bean that will go out and refresh that as we go. So I'm going to create a pullable bean. This will be as a supplier. It will provide a supplier. And again, we're going to supply a flux of aircraft. And a flux is a reactor type of a reactive streams publisher. The publisher can be 0 to N with Pivotal and now VMware's Project Reactor. Actually, we felt it made a lot of sense to break that kind of generic publisher, which can be 0 to N, into 2 types. A mono, which is 0 or 1 type, which roughly corresponds to an object if you're returning an object, for instance. Or you have a flux, which can be 0 to N. So usually it's a small group. Maybe it's a large, never-ending group, right? So that could be a kind of thought of as a reactive list, even though that's a gross oversimplification. But it allows you to think of things in terms of, say, an object of type T or an iterable of type T, but reactively. And that's what a flux is. It's kind of that reactive list of things coming through. So we're going to supply a flux of aircraft here. We're going to call this send aircraft. And this, if you look at a supplier is what? A functional interface with a single abstract method. And since Java 8, what can we do when we have a functional interface with a single abstract method? We can supply a Lambda for the implementation, right? So we're going to, well, we need some way to poll, right? We need some way to poll that device and say what aircraft are within range. So I'm going to create a web client here. Client equals web client, oops, back that up, web client dot create. And we'll point to our device here, actually our other application, which I've created to collect this off our device, local host, and that's at port 7634, add an endpoint called aircraft. There we go. Okay. Web client is the reactive web client defined within Spring Web Flux, or the reactive components of Spring. And of course, it's easy to go from non-blocking to blocking, not so easy the other way. So everything kind of starts off with a reactive focus, right? That's why I said I would be using reactive components here and reactive processes. But of course, going from reactive or non-blocking to blocking is very simple to step down. Again, not so much the other way. So I'm going to use our client, get my fingers on the right keys here, client, and I'm going to get, right? I'm going to just reach out and do a get, and then I'm going to retrieve the results. I'm going to convert that body, the response body, to a flux of aircraft, right? And let's see, and then, yeah, so then I want to, let's see, I want to filter this. So I want to take any aircraft coming through, and I want to make sure that the registration is not empty, right? And then I'm going to log that. So that takes care of that, I think. So yeah, that looks pretty good. Now I have a supplier here. So let's go configure our settings here. So I'm going to set the server port equals 0. For Spring Boot application, that just means it looks for any available port and uses that. So I don't have to assign a port manually or worry about port conflicts. Ooh, we are close on time. How did this happen? Probably too much explanation. But I don't know that you can say there's ever too much explanation, right? So we'll see. So we're going to bind that to our send aircraft channel. Now I'm going to use the function name here, the supplier name, the bean name, and then a channel. So out. So you have output channels and input channels. In this case, for our source, we literally, as a source, have output channels. And we can have up to 8. Right now, we just have 1, so we'll make that -0. And we'll set up our destination, and we'll call that a pipeline of processor. And then what I can do is set my binder. Since I have 2 of them on my class path, I need to indicate that I can use Rabbit or Kafka. I'm going to just set it to Rabbit. And I'm going to say that if we have time to go with our Kafka, Spring Cloud Stream Kafka, I want to be able to auto add partitions. And I also want to set the minimum partition count of 4. And I don't think we're going to have time to show actuator now, darn the luck, but I want to always say, don't do this in prod, because opening up and including all actuator endpoints for everyone who may want to access your app is not a good security posture to embrace. So I do want to just make that very clear. So we have our source. Let's go ahead and let's quickly build our processor in sync, because why not, right? We've got 4 minutes. We can do this. All right, so processor, and let's open that up. Where did it go? Open. There it is. Okay, that's fine. And I'm going to go back to my source. I'm going to do something I'm not very proud of, but time being what it is. So I'm having to look around my microphone here so I can get to my keys on occasion. So we'll go to our application properties. We'll go to our application. I'm going to go ahead and just copy in my aircraft. I'm going to make this an add all args constructor. And this, as a processor, is our transformer, right? So I'm going to transform objects of type aircraft to objects of type essential aircraft. And let's see, so we want a private string call sign, reg, and let's do type and manufacturer, right? So that probably will be enough. We don't necessarily care about the rest. Now I want to create a constructor. I'm going to bring that in, and then I want to just set manufacturer to typing helps, manufacturer using the type, and then of course it wants me to create that. I am actually going to just go grab some code to, again, copy code. Whoa, I just feel so terrible right now, but it does speed things along quite nicely. So that looks good. So there's our manufacturer. This allows me to based on the type, to determine who the manufacturer of said aircraft is. And that gets us down to business pretty quickly. I'm going to create another configuration class. This will be our aircraft transformer. And this will be a bean. We're going to define a function that will take a flux of aircraft, and return a flux, or produce a flux of essential aircraft. Come on, IntelliJ, keep up. There we go. Happy, happy. Okay, so transform, form, AC, and return. Now we'll take in an aircraft, or actually a aircraft flux, right? And we'll take that aircraft flux and we will map each one of the aircraft involved or within to a new essential aircraft. And we'll take our aircraft's call sign, our aircraft's registration, and our aircraft's type, and that will be sufficient. And then I'm just going to log that. So that's nice. Okay, so that should give us what we need. We'll go over here to our properties, server.port = 0, Spring Cloud Stream bindings, I should say. We have an input channel. This is a processor. So destination is processor. That's where we're getting these values from. Now I'm going to define a group that allows me to make this part of a competing or a consumer group, which allows me to implement the competing consumer pattern and thus scale. If you didn't do that, every consumer, every subscriber to this pipeline, if you will get a separate queue within Rabbit in this particular case, which means that you're implementing the fan out pattern. Everybody gets a copy of every message, which if you need to do that, that's a wonderful thing. If you want to scale, that's a bad thing, right? Because you want to be able to have multiple consumers assigned to a group, in this case, multiple processors assigned to a group, and then have them take turns. So I'm going to define, again, the binder as rabbit. And of course, now we have an output channel, transform AC out 0, and a destination. We'll call this sync. We don't need a consumer group here because it's not consuming on the output channel. But what we do need to do is, once again, set our binder to RabbitMQ. And then if we convert to Kafka at some point, hopefully, and minimum partition count 4, and we'll leave off with the actuator because that's probably just not going to happen. So I'm going to go ahead and start this. We'll see if we have that working. And while I do that, I'm going to go over and start working on the sync. There it is. And the sync is very straightforward, right? So once again, we have our application properties and we have our app. And once again, I'm going to go back here and copy paste. Whoa, just feel terrible. And then, of course, since we're transforming everything into an essential aircraft, so everything coming out, and actually I should make this at data, so we'll restart that. Everything coming out from this to be consumed will be an essential aircraft. And we can get rid of this, and we can get rid of this. Keep it simple, right? So at data, at all_constructor, and then we have our configuration class, and this will be an aircraft logger, and we're just going to consume that. So this will be a bean. It will define a consumer of a flux of aircraft, well, essential aircraft, import, whew, IntelliJ, you're killing me. And we'll just say this is logit. And this, of course, again, functional interface, single abstract method. So we will take our AC flux and we will do an AC flux and we'll subscribe to that and just print it out. Super. All right. Go back here, server port 0, Spring Cloud Stream bindings, and we have an input channel here. And our destination is sync, and our group is sync, and our binder is rabbit. And in case we do get to Kafka, which again, probably just wishful thinking at this point, but hey, let's try this. And let's run this. Oh, we're over. So once we get this working, then I'll go ahead and wrap up, give you the repo links, and we'll just call it a day and maybe see you in the next session. So we're off and running here. That's working. Of course it works. Everything always works perfectly in live demos. And I go off to the source and we start that. Oh, look at that. So we're processing aircraft. They're coming through and they're getting all the way to the end. So didn't get to show you some of the stuff that I wanted to show you, but hey, we've covered a lot of ground here today. So let's go back here. If you want to know more, please check out the GitHub repos at Game of Streams Aircraft Edition under my GitHub account, MKHeck. If you want to know more about writing the same code in Kotlin, actually, there's a Kotlin edition listed down at the bottom. And then, of course, if you want to know just in general more about Spring Cloud Stream, the Spring Cloud Stream project page is there. If you want to contact me, have questions, comments, or feedback, you've got my email addresses there, my two favorite anyway, and Twitter, MKHeck on Twitter. So that's absolutely the best way to reach me. Hope to see you there, and hope to see you in a few minutes here for the Spring Boot Omakase Talk. Thanks for coming. Have a great day.